Let us go through some of the follow-up questions to the REST API description that we have just talked about. So what does REST stand for and what makes an API RESTful? REST stands for Representational State Transfer. It's an architectural style, not a protocol, for designing networked APIs. An API is RESTful when it follows six key constraints. First thing is it is stateless, meaning each request contains everything the server needs to process the request. It uses a client server architecture. It is cacheable. It has a uniform interface, meaning consistent URLs and HTTP methods. It is layered so the client does not know if it's talking to the server or a proxy. And optionally, it supports code on demand like sending JavaScript to the client. In practice, the most important ones are statelessness, uniform interface, and client server separation. Next question, what is the difference between put and patch? Both put and patch are used to update a resource, but they differ in scope. Put replaces the entire resource. If I send a put request for user number 42 and only include the name field, the server replaces the whole user object. Any fields that I did not include get wiped out. Now, on the other hand, patch does a partial update. I only send the fields that I want to update or change, and everything else stays as it is. So if you compare put and patch, patch is much safer and more efficient for small updates. Put is better when you intend to fully replace a record, but you have to be careful if you want to use put instead of patch. A user tries to delete a record they don't have permission to delete. What status code do you return and why? The answer is I would return 403 forbidden. Here's the distinction I always keep in mind. 401 request status code means it is unauthorized, means the user is not authenticated, they haven't logged in, so we don't know who they are. Now 403 forbidden means we know exactly who they are authenticated, they have logged in, but they don't have permission to perform the action they are intending to. So if someone is logged in and tries to delete another user's record without administrator rights, that's a 403, not a 401. The server understood the request, it just refuses to authorize it. Next question, why is statelessness important in REST and what's the trade-off? Statelessness means the server does not store any client session between requests. Every request must carry all the information needed to process the request, typically through a token in the authorization header. The benefit is scalability because no server holds session state. Any server in the cluster can handle any request. You can add or remove servers as you like it freely, and load balancers can route requests anywhere. It also makes the system easier to reason about and debug. Now the trade-off is that every request is slightly heavier because it is containing all the information required to process the request. You are sending a token with every call instead of relying on a stored session. And if you need to invalidate a token, say on logout, it's harder than just deleting a server-side session. That's why token blacklisting or short expiry times are common patterns. Next question. How would you design a REST API for a simple block that is posts and comments? So the answer could be I would start by identifying the resources for posts and comments. For posts, you have get slash API slash v1 slash post. This is going to list all posts but with pagination. Then let's talk about post slash API slash v1 slash post. This is to create a new post. Then next is to get a specific post that would be get slash API slash v1 slash post slash 42 for example. Now, if in order to update a post, we will be using either put or patch. If it is partial update, we'll be using patch slash API slash v1 slash post slash 42. And if you want to delete a post, then you would need to have an information about the post number, right? So that would be 42. So we'll be using delete slash API slash v1 slash post slash 42. For comments, since they belong to a post, we would have to nest the comments within a post. So for all comments on post 42, we would have get slash API slash v1 slash post slash 42, then come slash comments. Now if you want to add a comment, you would be doing a post, that would be post on API v1 post 42 and comments. Then if you want to delete a specific comment, the command that you will use is delete slash API slash v1 slash post slash 42 slash comments slash 7, in case we are deleting the 7th comment. Now I would return 201 on successful creation, 204 on successful deletion but returning nothing, and 404 if a post or comment does not exist or not found. I would also add authentication, so only the author can edit or delete their own content, and returning 403 if someone else other than the author tries to edit or delete the content. How do you secure a REST API is the next question. So the model answer is by the use of several layers. First and foremost, the most basic one is always use HTTPS protocol, so data in transit is encrypted. Never expose an API over plain HTTP in production. For authentication, I use JWT bearer tokens. JWT refers to JSON Web Tokens. The client logs in, receives a token and sends the token in the authorization header on every request made to the server. The server validates the token without storing the session state. For authorization, I check that the authenticated user actually has permission to perform the action, not just that they are logged in. So we have authentication and then authorization. Beyond that, input validation on every endpoint to prevent bad data or SQL injection, rate limiting to prevent abuse and brute force attacks, CORS configuration so only trusted origins can call the API, and I would never expose internal error details in responses, log them server side but returns a generic 500 message to the client so I don't leak implementation details to an attacker. 500 message indicates that it is a server side error. Next question. What is idempotency? Which HTTP methods are idempotent and which are not? Idempotency means that calling the same operation multiple times produces the same result as calling it once. The server state after one call is identical to the state after 10 calls. Get is idempotent. Reading data does not change anything. Put is idempotent. Replacing a resource with the same data repeatedly ends up with the same resource. Delete is idempotent. Deleting something that's already deleted still results in it not existing. You might get a 404 on the second call, but the state is the same. Patch is technically not guaranteed to be idempotent depending on implementation. For example, a patch that says increment count by 1 is not idempotent. Post is not idempotent. Calling it twice creates two resources. This matters in practice because clients can safely retry idempotent requests if a network failure occurs without worrying about duplicate side effects. Next question. Your REST API get slash users is returning 50,000 records and the response is taking 8 seconds. How do you fix it? Now, first response of mine would be that this should not be the case. No endpoint should return 50,000 records at once. We need to add pagination. I would approach this issue in layers. I would add limit and offset or cursor based pagination, something like get users page equal to 1 limit equal to 50. The client only get what the client needs. Second is database indexing. I would check if the query behind this endpoint is doing a full table scan. Adding an index on the columns used in where or order by clauses can make queries orders of magnitude faster. Third, select only the needed fields. Instead of doing select star, I would only return the fields the client actually needs, reducing the payload size. Fourth is caching. If this data does not change frequently, I would add a cache layer, either HTTP caching headers like cache control or a server side cache like Redis, so we are not hitting the database on every request. Fifth, if all else fails at scale, database read replicas to distribute the load.